So here we shall solve the exercises. So here it is told that OA in figure 1, OA equals to OB and OD equals to OC. So that triangle AOD is congruent to triangle BOC and AD is parallel to BC. So first we will write what is given. So given is OA equals to OB and OD equal to OC in triangle AOD and triangle BOC. So then we have to prove that. To prove the first part is that triangle AOD, that is congruent to triangle BOC. Then the second one is AD is parallel to BC. So the proof is that I will tell that in triangle AOD and triangle BOC, OA equals to OB, which is given, and OD equal to OC, which is also given, and the vertically opposite angles are equal since it is shown that the line CD intersects the line AB at O. So therefore I can say angle AOD that would be equal to angle BOC since they are vertically opposite angles. Since vertically opposite angles are equal. So therefore I can say therefore triangle AOD is congruent to triangle BOC by the SAS rule. Since why here the angle which we took, that is the included angle in between the two sides, that is also equal. So it means by SAS rule of congruency, the two triangles are congruent. So by SAS rule of congruency, you can say that the triangle AOD is congruent to triangle BOC. Then we have to show that AD is parallel to BC. So now therefore we can say that angle ADO that will be equal to angle BCO. Angle ADO will be equal to angle BCO since why the by CPCT since the corresponding angles will be equal in the congruent triangles. Now since these two are alternate interior angles, so I can and DC is the transversal. So BC I can say BC will be parallel to AD. So angle ADO is equal to angle BCO by CPCT. Then I will say, therefore I can say the alternate interior angles are equal. Alternate interior angles are equal, and CD is the transversal. CD is the transversal. So therefore AD is parallel to BC. I will say AD is parallel to BC. So then I write hence proof. Then question number 2. Let's solve the question number 2. This is question number 2, and the figure is like this. So this line extends till I. The figure is actually like this. This is P. This point is I. This is P. This is A, B, and this point is C. And these two are equal. So AB is a line segment, and line L is the perpendicular bisector. But this is not I, this is L. So line L is the perpendicular bisector. It means that L is perpendicular to AB. As we told, L is perpendicular to AB. And if a point P lies on L, so that point P is equidistant from AB. So it is given that L is the perpendicular bisector of the line segment AB, and P is a point on it. P is a point on the line L. Then we have to prove that P is equidistant from A and B. Means we have to show that A equal to B. Now the proof is like this. We have to see that in triangle ABC and triangle BPC, APC and BPC, PC is the common side. PC is the common side. Is the common side. And AC equal to BC. AC equal to BC, which is given. Since what is told, L is the perpendicular bisector of AB, which means that AC equal to BC. Is a point on the line L. And then it is told that angle PCA, that is equal to angle PCB, equal to 90 degree. Therefore, triangle APC will be congruent to, since why here by SAS rule, since why PC is the common side, so PC will be equal in both the triangles, and AC equal to PC, which is given, and angle PCA, that is equal to angle PCB, which is 90 degrees. So triangle ABC will be congruent to triangle BPC. So by SAS rule of congruency. SAS rule of congruency. So hence, so I can say that AP will be equal to BP by CT. So hence we can say, hence the point P on the line L line L is equidistant from the points A and B. Equidistant from the points A and B. So hence proved. Then we will do question number 3. This is the question number 3, and its figure also has been shown. The figure is this one. So it is told the line segment AB is parallel to another line segment CD, and O is the midpoint of AD, and show that triangle AOB is congruent to triangle DOC. And O is the also the midpoint of BC. So now it is given that AB is parallel to CD and O is the midpoint of AD. O is the midpoint of AD. And we have to prove that first part is triangle AOB that is congruent to triangle DOC. And O is the midpoint of BC. O is the midpoint of BC. And the proof states that okay, so the proof will be that I will tell that in triangle, so these two are parallel, means AB is parallel to CD, it has been told, and O is the midpoint. So OD equal to OA, it has been told. And so since these two lines are parallel, so I can say the alternate interior angles will be equal. And you can say these two angles are equal, and we can say that these two we should not use. And we have to say the vertically opposite angles are also equal. So then we can show that these two triangles are congruent by ASA rule. Means angle side angle. Since the side which we will take, that is the included side. So this one I will tell that in triangle AOB and triangle COD, angle AOB that is equal to angle COD. Since why they are the vertically opposite angles, vertically opposite angles, and angle ABO that is equal to no say that angle BAO that is equal to angle CDO. Since y alternate interior angles are equal, since y here it is given that AB, since I will tell, since AB is parallel to CD and AD is the transversal. Is the transversal. And I will tell AO is equal to OD. Since why it is given? It is given that O is the midpoint of AD. So AO will be obviously equal to OD. So therefore I will say that triangle AOB that will be congruent to triangle COD AOB that will be congruent to DOC. Since why here we can see that the point A corresponds to D and B corresponds to C. So I should tell AOB is congruent to triangle DOC. So how? By ASA rule, by angle side angle rule of congruency. Since why here we have taken two angles and the included side of those two angles. So the first part has been proved, and O so is the midpoint of BC. So we can also say that BO that will be equal to CO by CBCT, which means corresponding parts of congruent triangles. And hence we can say that hence O is also the midpoint of BC. O is the midpoint of BC. So hence O. Now fourth one. So AC is equal to AD and AB bisects angle A. And AB bisects angle A. So that triangle ABC is congruent to triangle ABD. So what can you say about BC and BD? So first we will write what is given. The given is in triangle ABC and triangle ABD. You can see that AB is the common side. AB is the common side, and obviously AC equal to AD, which has been told, and AB bisects angle A. AB bisects angle A, and we have to prove that triangle ABC is congruent to triangle ABD. And we have to tell something about BC and BD. So if ABC is congruent to ABD, then obviously BC will be equal to BD. So that also we have to prove. we have to show that BC equal to BD also. Since why? By CP, only we will get that. So then the proof will be like this. That is, um, the second one we have to show this actually. We have to. It is not told to prove. We have to just find what we can say about BC and BD. Okay. So in the proof, we will say that we will tell in triangle ABC and triangle ABD. AB is common side, so AB will be equal in both the triangles, and AC equal to AD, which is given also. AC equal to AD, which is given also, and angle BAC that will be equal to angle BAD. Why? Both will be equal to half of angle A. Since why it has been told AB is the bisector of angle A, so each of them will be half of angle A, which is given that AB is the bisector. So, so we can say that triangle ABC that is congruent to triangle ABD. How? By SAS rule. Since why we have considered two sides and their included angle. The two sides and the included angle of triangle ABC, that is same as the two sides and the included angle of triangle ABD. So triangle ABC is, since why here this we have considered this side and this side, so this one is the included angle. So with this triangle BAC is also half of angle A, and this is also half of angle A. Now this angle is also the included angle of these two sides AB and AD. So it means I can say that ABC will be congruent to triangle ABD by SAS rule. SAS rule of congruency. Then, so therefore we can also say that BC will be equal to BD. BC that will be equal to BD. Since why? By CP. So hence we can say, hence it has been proved that ABC is congruent to ABD, and so we can say regarding BC and BD, we can say that they are equal in length. So we can say that BC and BD are equal. Similarly, the reason I will tell, since the reason also we should tell that since they are the corresponding sides, since they are the corresponding sides, or I can say they are the corresponding parts of the congruent triangles. The congruent triangles, which are ABC and ABD. Then have to solve the fifth question. So ABCD is a quadrilateral in which AD equal to BC. BCD is a quadrilateral in which AD equal to BC. Angle DAB equal to angle CBA. So it is told ABCD is a quadrilateral in which AD equal to BC and angle DAB equal to angle CBA, and then it is told to that triangle ABD that is congruent to triangle BAC and BD equal to AC and ABD equal to angle BAC. Okay, so we have to first write what is given. Given is ABCD is a quadrilateral. It is a quadrilateral in which AD equal to BC and angle DAB equal to angle CBA. And we have to prove that first one is triangle ABD that is congruent to triangle BSC. Second one is the PT will be equal to AC. Third one is that angle ABD that will be equal to angle BSC. So here, first we need to try the construction is not required since here the diagonals AC and BD has been already drawn. The proof is that I will tell in triangle ABD, triangle BSC, AB is the common side. AB is common side and it's told that AD equal to BC, that is given, and angle DAB that is told that is equal to angle CBA, which is also given. So here we can see that we are using the two sides and the included angle. The two sides and the included angle in triangle DAB, that is same as the two sides and included angle in triangle DSC also. So I can say therefore, and here we can also see that the point A corresponds to B and D corresponds to C. So when we write ABD, so B will correspond to A also. So it means that when we write ABD, triangle ABD, then that will be congruent to triangle the BESC. So therefore we will say triangle ABD that is congruent to triangle BSC. How? By SAS rule, by side angle side rule of congruency. By SAS rule of congruency. And so I will say so BD will be equal to AC. And angle ABD that will be equal to angle BSC. Angle ABD that will be equal to angle BSC by CBCT. So I will tell hence Then we will solve question number 6. So this is the question number 6. The figure also has been shown. Figure is like this. So here it is told AD and BC. AD and BC are perpendiculars to line segment AB, so that CD bisects AB. CD bisects AB. So what is given? I will write that first. So that is AD is perpendicular to AB, and also BC is perpendicular to AB. And then obviously CD, the line segment CD is drawn. CD is drawn. So it means two triangles are being formed, as you can see. One is CBO and one is DAO. We have to prove that CD, the line CD bisects AB. CD bisects AB. Or we can also say that OA equal to OB. So how to prove it? We have to take the two triangles. One is triangle DAO, and triangle CBO. We have triangle DAO and triangle CBO. Angle OAD, that is equal to angle ABC. Since why both are equal to right angle, both are 90 degree, it is given only. Since why it is told that AD is perpendicular to AB and BC is perpendicular to AB. So this is given in the question itself. And we can see that it's told that AD equal to BC is given also, and angle AOD, that is equal to angle BC, this is given also. Given. No. Angle AOD is equal to angle PUC. This is not given. This is These two angles are equal, AOD and BOC. Since why they are vertically opposite angles. Means vertically opposite angles are equal. Opposite angles are equal. And so therefore, I will tell that, see, here we have taken two angles and one non-included side. This side is not included within these two angles. So therefore, they are congruent by AAS rule, which is angle side. So therefore, I will say that triangle DAO is congruent to triangle CBO. How? By AAS rule, angle side rule of congruency. Angle side rule of congruency. Right. So I will say that. So obviously AO, that will be equal to BO by CPCT. Since AO is equal to BO, so therefore we can also say that the CD, the line CD bisects AB. So hence P2. So hope all of you understood the solutions of all these 6 questions in the exercise 1. Still any doubts, if you have, please write that in the comments. The remaining questions we shall solve in the next uh, part. So thank you everyone. Bye.